Okay, so let's go ahead and look at some mixture, motion, and finance problems from section 3.4. The first one I want to do that I know one of you had asked about is number 29. Or maybe I just picked that one because it was a motion. But I think this will be a good example on something. So if you want to look at number 29 on page 220. Okay, so number 29. And the problem reads like this. It says, Dom leaves his house at noon and rides his bicycle south at a uniform rate. His wife, Sue, leaves at the same time, heading due north. Dom's rate is approximately 10 kilometers per hour faster than Sue's rate. At 5 p.m., they are 160 kilometers apart. Let's find the rate of travel for each cyclist. So really, in order to think about starting this problem, the one thing that we have to remember is the equation for distance equals a rate times time. Okay, D equals RT. Now, if you think about it, the total distance is the rate and time that Dom traveled and also the rate and time that Sue traveled. So I'm going to write it like the total distance is equal to the rate of Dom plus the rate of Sue. Okay. And the time is the same for both. They both were traveling for 5 hours. So we're just going to say times 5 hours. Okay. Now, what makes this problem tricky is that we have to be able to distinguish. We know that Dom's rate is 10 kilometers faster than Sue's rate. So we can write everything in terms of Sue's rate. We also know that the distance, the total distance, was 160 kilometers. And so we know that, and we know that the rate, and this is kind of supposed to be a subscript here, but the rate of Dom is 10 kilometers per hour plus the rate of Sue. Okay, so now I'm going to plug all of this information. I'm going to plug this in right here for Dom, and I'm going to plug this in right here for my distance, and then we're going to solve for the rate of Sue. Okay, so let's see, I have 160 kilometers is equal to 10 kilometers per hour plus the rate of Sue plus the rate of Sue times 5 hours. Okay, so all leading back to this parent equation up here. Now I can simplify this just a little bit. So I'm going to say 160 kilometers is equal to 10 plus 2 times the rate of Sue. Okay, and all of that is still times 5 hours. Okay, and now we can go ahead and distribute this 5 through here. So I get 160 is equal to 10, no, sorry, not 10, 50. Okay, plus 10 times the rate of Sue. Okay, and now I'm going to go ahead, this is my variable. This whole thing right here is what I'm solving for. So I'm going to go ahead and subtract off the 50 kilometers from each side. Okay, that leaves me with 110 kilometers equals the rate of Sue. Okay, times 10. Okay, sorry about that. Usually I put that 10 in front. Maybe I'll just quickly erase that here. Let's see if I can figure out how to do that. There we go. Let me just rewrite that really quick. Okay. 10. Right, Sue. There we go. That's better. Okay, and now I'm going to divide both sides by 10. Okay. And keeping in mind that we know that rate in this case is kilometers per hour. So I know it looks kind of funny over here, but really what you have up here is the kilometers on top here and then an hour on the bottom. So I know it looks goofy, but we've got 11 kilometers per hour equals the rate of Sue. Okay. And if we know that Sue is at 11 and that Dom was 10 miles or 10 kilometers more, then we know that Dom traveled at a rate of 10 plus 11, which would be the 21 kilometers per hour. Okay. So that's one example. Okay, the next example I'd like to look at that I know some of you also had questions on is number 35.